Hello.
Hey, how are you?
Good, how's it going?
All right.
Hey guys.
Hello. It is finally above freezing here. So piles of snow might start to recede. That's been nice.
Are you in New York?
New York area. I'm up in Connecticut.
Cool.
What about you?
I
Currently in Menlo Park, but based out of London.
Ah, oh, okay, there you go. How's the weather in Menlo Park?
Yeah, it's like 19 degrees Celsius. How much is that in Fahrenheit?
Nice. Yeah, very good. That's nice degrees Fahrenheit, I think. 60 something.
I'm in Austin, and we had like 2 days of winter. Now that's over. So yeah, it's hot, hot, hot.
How are you, Thor?
Yeah, also doing great. So bit of winter is going away now. Yeah,
Get out
temperatures are
for
rising.
runs
Yeah.
much these days?
Yeah. Twice a week.
Nice.
So should do run on the conference next time again. Yeah.
Yeah, I'm down.
Yeah, sure. Cool.
GraphQL run.
There's a lot of space here to go for a run. Yeah, like
Nice.
run around run around the office.
That'll be fun.
Cool. Yeah, I just booked flights for like 2 weeks to
Nice.
California. Yeah.
Oh, good for
Nice.
you.
Yeah.
Hey, everybody.
Kuwait is gonna be like 15 minutes late. So I don't know how often we should give people some time to join. But then I guess at some point start with some intros.
Yeah,
Yeah,
we can get started.
if Koi is going to be a couple minutes late, then yeah, we should have someone do the official preamble and hosting and all that.
Yeah. She asked me to take over her and do that. But I was like, so I just go over the agenda, yeah, and intros. So yeah, I think maybe we should start with some intros, and then we can go over the agenda items. I don't think there's anything that was ready for review, so I had to look over. But anyway, yeah, so I'll start with my intro. Say hi everyone. I'm Alex. I work for Meta with Kuwait. I think Jose is also here. I think I've seen him join. Usually based out of London, but visiting the office here in Menlo Park this week. Passing on to Mark. You want to go next?
Yeah, my name is Mark. I'm in Austin. I work for Yelp. And yeah, just to kind of make sure we've covered our bases, all participants have agreed to the specification membership agreement in this meeting, participation guidelines, contribution guide, and code of conduct. These meetings are recorded and automatically published to YouTube, and we may use LLMs and AIs to generate summaries. Yes, and then on to whoever's next on the agenda list. Which I believe is Dale.
Yeah, Dale's hasn't joined us yet, so I think we're down to
Yeah.
Michael.
All right. Hey everyone, I'm Michael Rebello. I work for Airbnb. I'm on the basically the client GraphQL infrastructure side, and so I've been spending a lot of time over the last year and a half working on tooling related to AI and GraphQL internally. So it's great to meet you all. I'm in Southern California in San Diego.
Next is Pascal. I don't know if Pascal has joined yet.
No, Pascal. I think I'm next. My name is Martin. Hello, everyone. I work at Apollo with Jeff on the mobile clients mostly. It's my first AI working group, and I'm happy to be here. I think next we have Tore. Yeah.
Yeah. Hey everyone. I'm Thor. I'm from Germany, Cologne. Yeah, working on the GraphQL working group. So experimenting a lot with MCP servers, GraphQL related, more of the machine learning background side. But yeah, excited to join.
Hey, everybody, I'm Jeff, joining you from Monroe, Connecticut in the US. I work at Apollo. Think
Hello, I'm
Steven?
Stephen. joining you from Chattanooga, Tennessee, and I work on platform at Netflix.
Jose, you want to go next?
Yeah, hey everyone. I'm not on the agenda, but my name's Jose. I work with Alex and Koei on GraphQL here at Meta. I work on GraphQL integrations, so all the client-side integration work, both for agents, but also into all the infrastructure that we have across the company. Nice to meet you all.
And I think Gene.
Hi everyone, I'm Jean Lucas. I'm from São Paulo, Brazil, and I work as DevRel for Viaduct.
Cool. Thank you. I think that's everyone, from what I can see. Yeah, we're missing Koei and Dale, but hopefully they'll join. Mark, can I ask you to help me go over the grants? I don't know if you mentioned that.
Yes. Okay, so let me pull it up. I believe that okay, I'm trying to find the exact wording to say. Basically, there is grant money available. If you work on projects related to GraphQL under the GraphQL Foundation, then you should apply for grants. There is still grant money. Yeah, that's the thing to say about that.
Cool. Thank you. Thank you so much. Pascal, I just saw you joined. Do you want to give a quick intro?
Yes, already on topic.
Also, just in yourself. I think there's some people joining. Just give a quick join yourself, and then I think we can go over to your agenda item, which is your demo, right?
Right. Perfect. Yeah. I'm Pascal from Chili Cream.
Rami from Airbnb.
And then anyone who did not add themselves to the agenda, you can please do so. That'd be good.
Well, I think the only item we have for today is the demo, right, from Pascal. I don't see anything else on the agenda on GitHub.
Since we have all the people available, I suspect we may want to talk about mocking as well, which I know has come up last time. So if people do want to chat about that, we can do so if time allows. It wasn't explicitly added as an agenda item, but yeah, there may be some interest in that. We'll see.
Okay. So, do you want to go first, or should we do a semantic introspection first? I don't mind. I probably don't have longer than 15 minutes, so.
Let's go for it.
Right, cool. So for the ones which haven't seen it yet, there is a pull request. No, actually, it's already merged. It's an RFC about semantic introspection. You can read it in piece at some point. Essentially, what it discusses is how MCP currently is very hyped and exposes a lot of tools, while actually in GraphQL we already have MCP because with MCP you expose your tools and you have a JSON schema which describes what you can do and yada yada yada. And we actually have this already with our GraphQL schema because we have mutations, we have queries, and we can actually find out what you can do and how you can do something on our API very, very easily. The problem is the size of a GraphQL schema because especially when you play with the big players and you see a schema of Facebook or something like this, then this just doesn't fit into the context window, and you don't even need gigabytes of schema files. It's already when you have a decently sized API, then your context window is already blown. So what semantic introspection does essentially is it proposes an extension to the introspection where we expose something which is called __ search, where you can pass in natural language queries and you essentially get back search results which are which have a location, which define the member. So this would be a field, an object, or whatever. It defines paths to root. We'll see this in a second. And it also defines relevance scores. So how relevant this result was for the overall the query that you have sent. So this essentially tells you how well this fits with your request. The schema member union essentially is just a union of the schema members, and then you can do things like this. You can write a query and you will get back the fields which match your request, the most likely fields that you want to request. Okay, this is how this was a couple of weeks ago already. Now there is a pull request open to this because we have an implementation of it, and it essentially extends this with the coordinates fields. And the coordinates field adds a second extension to the introspection where we can now fetch coordinates. No, where we can now fetch coordinates. So we can pass in an array of coordinates and we will get back the respective schema members for these coordinates. And that's quite handy because here we get an array of coordinates. That's actually wrong because it's a nested array. But here we get an array of paths, which a path being is an array of coordinates. And we can now look up these paths by using this resolver. So we'll see in a minute what AI does with it. Cool. Now, before we go into this, why not just have a look at
demo?
a demo.
Wow, a demo.
There we go. Let's look at the real thing, right? So now what the LLM will do is what we play around with here. So we say we can now query essentially this API and we can ask, what is my latest commit? This is the GitHub API behind the scenes. Now what we get back is we get the coordinate, the pull request merge commit, which is a field on the type pull request. And we get member information. So we know the description of this field, we know the name, the type name, the field name, and so on, if it's deprecated or not. And then we get these paths to root. And the path to root is essentially how do we get from pull request merge commit to the root, so to the query type. And this essentially is a list of fields that we have to walk up. And you see there's multiple ways how we get there. So one is, for example, here over the query relay resolvers, whatever this is, we have the organization and we have the repository, which both have these information. And then we have the score, and you see it's not really sure if this is what we were looking for, because in fact, GitHub doesn't really have a way to return your latest commit. Now, once the LLM has searched and decided what the important schema members is, it will use, or it can use, the coordinates field to actually fetch the details about the coordinates so it can build a query. So it's just okay, let's go back up again, run this quickly. When we look at this, we see that here we have just the merge commit field, right? And when we only have this, we have no idea if the pull request has arguments. If so, what arguments does the pull request have, and so on. Now, by using the coordinates resolver, we get all of this information. So we now know that the repository field actually has, the query repository field actually has two arguments that we have to pass in, the owner and the name. And we know that the pull request field actually has an argument itself, which is just a number. And the commit doesn't have. So when we want to take this path to build our query, we now know that we have to have at least 3 arguments in our query. Okay. The LLM now will take this information and will build a query out of it. It's actually quite successful at it. I'm surprised myself, but it actually made it. So now you have this, and then the third component that you have to do is validation. And this may or may not be an extension to the HTTP specification, to the GraphQL over HTTP specification, because there needs to be a way how we can validate a query. Now, in the implementation I will show you, I hacked this by just doing this and abuse the GraphQL validation to actually validate my query like this, and I just skipped the whole execution. Of course, this is not really efficient because this just skips the execution, but you would still have the whole query planning and whatever happens behind the scene. So in case of this is just my way of telling the server how it can actually validate the query that it has generated. And if it's a valid query, then it will propose this to the user. If not, then it will obviously not do this. Okay. Now, let's have a look at the real deal. So for this, I need to find my sharing window.
Just so we're on the same page, so the 2 executions that you did, none of them has LLM. They're just MCP tools, which like calls into a RAG or something and then returns, right? And then next one, we're gonna have like see how an LLM is using these GraphQL introspections.
Yes. For RAG, we need to have the AI involved as well, right? We get the string, we translate the string into a vector, and then make a similarity search. This is a bit. This is something which is a bit which hurts a bit because I really try to avoid like having LLM calls in introspection. I mean, not LLM, but embedding calls in introspection, because that's something that you essentially have to pay for. I mean, there is models that you can run also on your CPU. I don't know how well this works. It's something that we would have to see. But for RAG, like you would have to embed, but at the same time, you also have to do it on each request.
Yeah.
Okay, so what we can do is we can now say, who is the top contributor of the relay repository of Meta? But let's do it this way. Build me a GraphQL query. Shows me who is the top contributor of relay, blah, blah, blah. Now, slight hint. Just to make sure that it doesn't go crazy. We have to obviously use the magic MCP. I'll get to this, what this actually is. So, run GraphQL get coordinates. That's nice. That's exactly how I wanted to demo it. Okay, let's try something else. I need some input. What do you want to know?
The most followed GitHub repo.
Generate me a query using semantic introspection. GitHub is, I should have known it. GitHub is a bad example because the LLMs already know the schema a bit, so that makes it a bit easier for them.
Oh,
Generate the query using
yeah.
that shows me the most star GitHub repository. Ta-da. Come on, do a semantic search now. That's one thing when you do these AI demos, you know. Yes, it does a semantic search.
You did semantic search earlier as well, right? Your previous example.
No, it just did get coordinates. It faked it. It just
Oh.
directly called the get coordinates method, and then it just got the coordinates
Oh, you
back.
skipped to the first one. Okay.
So you see, it actually gets back the coordinates now, and it also gets the path to root and everything. And now, when it has searched, the search is done. It will use get coordinates. There you go. Uses get coordinates to get the detail of it. It validates the operation. And then it will output a valid operation that we can execute on our graph.
Awesome.
One thing that we didn't try out is to actually use the prompt I have, I believe. So when we say, let's try the same thing. Let's see if it's smarter if we do this. Or actually, did it
Actually,
use
what
it?
is your system prompt right now?
There is none.
Oh, okay.
There's none.
Nice.
The only thing I have is, okay, so it doesn't seem like it actually used my prompt. So let's see, when we do semantic introspection. Now the question is, how do you do this? There is a prompt in here. The graphical. Okay.
Oh, you mean in your tool description, like
yes,
description
yes.
for parameter and for return type.
Yeah, but I don't know how this works in VS Code, so I'll just copy the prompt manually. Because then you can obviously, that's the system prompt now. You can obviously hint a bit better, like what steps it has to take to actually get to the result.
Okay.
And that makes it maybe a bit easier for the LLM to actually get there quicker. But it does the same thing. So anyway, so I've played around with this a bit, and it's actually quite successful. I unfortunately archived all my queries by accident today, but I did it before this meeting to verify that everything still works quickly. And write me a query that shows the top contributor in Relay. It actually did a semantic search in GraphQL, and it then immediately did the get GraphQL get coordinates, did the validation, and then output the query here. Okay. Now you say, but hey, you cheated. You used an MCP. And that's true. I used an MCP. I'm guilty. But this MCP essentially is just to somehow get the AI to understand what it actually can do.
Yeah.
If this would be, let's put it this way, if this would be baked into GraphQL proper, then we wouldn't need into the LLM agents properly, then we wouldn't need an MCP server for it. But to make use of things like VS Code integration here, we obviously need an MCP, which defines a couple of tools. 1 second. This one formatted the stuff. There you go. And we have 3 tools. We have the semantic search, and this essentially just executes a graphical request. We have the coordinates, which is the same. So we just expose these tools. And I think when we go in here, we actually see this as well. So we just have the get coordinates, get type, semantic search, and validate operation. What you can do with the tool is with the prompts is you can steer it a bit. For example, it works quite nice when you actually tell it, first use semantic search to find coordinates that you want, then use the get coordinates to get the coordinates that you want. And once you know the path, then also use get type to get more information, or use get coordinates to get more information about the type, your leaf type. So for example, when you fetch an address and you want to know the street of your address, it will also, you can prompt it to say that include every other scalar on this field as well, which is interesting to the user. So we'll not only get the street, you will also get the city and whatever else, the zip code and so on. So it will make the query a bit richer, and you can steer it a bit like this. Okay. Any questions?
This is awesome. So I will just like maybe quickly, there are 2 points that I think for this extension, I really love it. 2 small things. One is my personal pet peeve, but I think it's important. Like GraphQL resolvers, names of the GraphQL resolvers should not be its input. It should be what it returns. So I just feel strongly we should not call it underscore coordinates, because that implies to me you're returning coordinates. You're not like it's right. You should not be named it based on what the input it takes, because this is a field that takes coordinates as input and returns some information. So that's just like a one thing. I think it's going to confuse a lot of people, right? You have a resolver names address, you expect it to return address. You don't expect it to take address as an input and return something else. Anyway, that's like a small pet peeve, but I think it's important like that we name it correctly so it helps us understanding. The second thing I have, oh, sorry, Michael, I have the second thing and I'll give it to you.
Go ahead. Yeah, go ahead.
The second thing is I know it's currently named coordinates, and I'm wondering if the return was already a little verbose. Like, can you just return an SDL for that thing that you're getting the coordinates from? I know it might return something weird if it's an argument, like the coordinate is an argument coordinate, but for the rest of them, it actually should be fine.
How do you mean?
Like basically, if a coordinate is a type, we just return the type SDL, right? And then if the coordinate is an argument, is a
Right.
field that you basically, it's the most concise way than what you have today.
So the reason why I build on top of this is because we already have this. It's introspection, right? So that's why I said that the only thing we need, you see, I faked it a bit. So for us having to have a properly functioning GraphQL server, and for us to have a properly functioning GraphQL IDE, which actually know that types and field exists, we cannot use the double underscore because this is reserved for GraphQL specific. So I used one underscore.
But if it's becoming a spec,
it would have both underscores.
Two underscores, yeah.
And also the IDs would know about it. Now, the union type that we return from the member is essentially just the normal GraphQL.
Introspection, I know the return type. Yeah, I am saying we could provide an additional, it's literally a string field that is the SDL representation. And I think it's the most token efficient, right?
That might very well be, yes.
Yeah.
I do, by the way, index JSON documents because I think you asked this last week. Like, how are the coordinates indexed? So I just create JSON documents and drag the JSON documents. I don't rag the SDL. I add all of the information. I build the JSON document and add all of the information I need, and then just drag it without any specific formatting or something. It's just a JSON.
Wait, so the whole thing, like you just like, here is my whole schema in a one big
No,
JSON.
no. For each coordinate, so I take the schema part, parse the schema, completely take it apart, and then for each type system member, I create a JSON document and I rag the JSON document. So for each argument, we have all of the information of the type, so that it is an argument. Then we have the information about the argument name, the type name, the field name, the description of the argument, the return type, and all of these things. It's just one JSON document. And this is what I rag with the batch index. And then this is my index to search on. So it's, I think GitHub Schema is like 8,000 of these. It's a few cents to index, yes.
Yeah, so that's actually different from what Thor indexed on, right? So my understanding is you do it at the type level, each type, all the information related to the type in a document, rag it. What Thor kind of maybe presented a couple months ago is at the field level, right? So if one type has 10 fields, you should create 10 documents and you rag 10 of them.
That's exactly what I do too.
Wait, so you do both, or you just do?
So the coordinate in GraphQL is either a type,
or a field, or an argument. Yes.
Exactly. So I do it for all of them. So
also, you rag at 3 levels. Sorry, I don't know since when rag become a verb, but whatever. Okay, so you actually do more. So you have 3 levels of ragging.
Yes, and then at the moment I need to check what we just looked. I think it's just an in-memory index. I think I'd keep it just in memory. I played around a bit with SQLite, which unfortunately doesn't really support vectors. I mean, it does, but not the good kind of vector search. So I played around with Postgres, which also worked well, but I thought in memory is the simplest. And then just store it in the rag it and store it in memory.
Is it a hierarchical lookup then, or is it like on the flat embedding lookup? So you have like the flattened level lookup, or how do you retrieve that?
How do you mean flattened level? So it's just one flat table with the vectors and the coordinates. Nothing.
Yeah, so you don't embed type and then again embed type field level, so that you have a hierarchical abstraction. You don't have 2 lookups, you have only one.
Yes,
top K lookup. Yeah, okay.
Yes. Just make it as simple as possible.
Yeah, okay. So that's similar to hide, I think, yeah.
In a very pathological case, you could return like your top 10 candidates is all just argument. And then you don't have anything to actually construct, right? I'm just saying it's possible.
Might need to rebalance that, yeah.
Yeah. Okay, but it works in practice. Okay.
Yes.
Michael?
Yeah, thank you. I have, it's kind of 2 questions that are sort of intertwined, I guess. The context is that I built something, it doesn't work semantically the same way as what you built. This is really cool, but we built something a little bit different at Airbnb, which is used for the same purpose, so for searching the schema, feeding the data back to LLMs, and then producing queries based on that. So I'm happy to share more about that at some point if folks are interested. The question I have is if you've considered including directives in the responses that you provide back. I know this is missing from introspection today, which was one of the challenges that we ran into. One of the reasons for this is there's some semantics that can kind of exist in the schema which indicate how queries should be structured. So I can think of like a couple off the top of my head where we have, like in addition to deprecated, we have kind of the polar opposite at Airbnb where you can mark something as canonical, which means that like out of 20 different types that like sound very similar, this is like the one for X, Y, and Z use case. And so that can be used as a signal for one, like ordering results in those APIs. So I can imagine, introspection takes into account some of these semantics. And then 2, the agent itself may need some directives that are present in the schema. So for example, one might be like @experimental in the schema, which requires like the client to opt in with the client side directive to actually like consume that and produce a valid query. So I think there's like a bunch of use cases for directives where it makes sense for the agent to need to know about what is present in the schema in order to produce a valid query. So I'm curious if that's something that you've considered as part of this RFC.
I think that's more of a way to think, like, this is hard because you now instruct not only the graphical agent to actually build a graphical API, you also instruct the agent. You have additional knowledge that the agent must have, which is in graphical specification related. So if I do a semantic search on all of the index coordinates and you have this canonical directive, this directive will never come up, right?
Right.
Because why should it? It's not what I searched for. So the agent will not know about it. I think you probably would have to use something like prompts in MCP for essentially instructing the agent to query the right thing, right? Or to know about these features when you have specific features. We did discuss something in the RFC about examples, that on types you could technically also have examples that show how you can query certain fields. It's not implemented in this specification yet, in this example yet, but theoretically you could probably use this. And you could probably say that when you have a field which is annotated with canonical, that then you have an example with a description that this is actually used in a certain way. And the LLM will probably pick up on it because it's a pattern that it can replicate, right?
Yeah, I think just to clarify, I'm talking less about like the directive definitions and more about this directive lives on X, Y, and Z field. And so what you said makes sense. Like I wouldn't expect the server's like semantic search to take those into account. Like I agree that's asking too much. I'm more of wondering from like, if I, as someone writing a GraphQL query, like even if it's in my system prompt or I use a skill or something to basically feed it extra context on directives that are in my schema, like third-party engineers who are building queries could basically, like people define their own directives. And so I think this would be a way for them to essentially extend what you have in order to build custom functionality by consuming directives that are present, like on either fields or on types. I don't know if that makes sense. Sorry if I wasn't clear in the initial question.
That makes sense.
Yeah, one other thing, Michael, I guess the thing here is I don't know if you actually need a search for directives. Just in practice, the number of directives that we have on a schema is significantly smaller than the number of types, right? We define in the schema. So a lot of times, like we might just we basically always instruct the agent to do two steps. One is you should write your fragment or operation without any of the directives. And then the second step is, okay, now you need to add the directives. And then for that, we could even just choose to show, here is all the available directives that you should use. And then based on what the user is telling you, because that can be actually easily fit into the context window. I'm wondering, what's your experience? I could be totally wrong. I just want to know.
No, I think you're right. I think you're very much right for directive definitions for the client to know about adding. Like we did something similar, like write the query, then figure out directives afterwards. I think the challenge I'm referring to is when the client itself, like it could be a step during writing the query or afterwards, but where the client needs to make a decision around either how they write the query or how they add client-side directives based on directives on the schema itself. So not like definitions of available directives, but like, let's say, I don't know, some types field is marked with some specific directive. Like the client has to make a decision on what to do with that field based on the directive's presence on the field itself, not the existence of the directive. Does that make sense?
So like schema level directives, like the non-null one was the one that kind of...
Correct. Something like that. Or like one of will be another one, right?
Yeah.
Like you would want the client to be aware of both of those.
Okay, so somehow the client needs to be aware of those directives that lived on the schema, and then it needs to behave differently based
Right.
on.
Exactly. Like a concrete example would be if you add one to an input and then you have an agent write a query and then you want the agent to actually execute the query, it has to know about the directive. Otherwise, it's going to produce an invalid input, right?
What would be very interesting to see is how the LLM behaves if you have this response here. And you would actually say that user via email has a, I don't know, canonical directive on it, or we have an input type which actually is flagged with one of. What would be interesting is if you prompt your LLM, so system instruction essentially, to query for these directives that it hasn't heard of, it might actually do it. And then you can have these behaviors that you add to your agent. So just in the normal search query stuff here. Additionally, we talk about examples that we essentially have on the types, and on the fields we have examples, which is a description and an operation. And now when a field is using one of your custom directives, or an input type is using one of, there could be an example how you actually use it, with only one field and so on, instead of more than one.
Yeah, that makes sense. Just to bring up from the chat, by returning STL, are you referring to actually returning like GraphQL text, like sub snippets, basically? Is that what you're referring to?
Yeah, so maybe using the null example, right? Like, so because certain types that supports the null is like, that's defined on your schema. So when you return an SDL for that specific type, then those directives that apply to that type will like all showed up. And then the agent consumes it, then knows like, oh, I need to generate my client code that uses this in certain ways.
That makes sense. For what it's worth, that's what we did at Airbnb, and it seems to be working fairly well for that too. And that's how we tackled the directive challenge as well.
Gotcha.
Was the
There
decision
are
made
some-
to not use that here for this?
I guess there are some directives like defer and stream. You kind of still have to make that decision separately, which is gonna be a separate step, right? All right.
I just realized that I lied to you guys. I'm sorry for it, but I'm honest enough to tell you. No, I've just checked the demo that we have seen, because I've tried both. The demo that we have seen actually uses not the JSON generated embeddings. It uses text, where I essentially create a string based on the information, so description, return type, and so on, and embed this. I have both, and the one that we just looked at did the text. I just checked.
It'd be interesting to see
bench-
like position and recall on this embedding differences. Yeah.
Yeah, I didn't benchmark anything. Sorry, I didn't benchmark. It's absolutely zero scientific, It's just, does it work? It seems to work. So there definitely needs to be benchmarks and such. Okay, so I can provide this as two things. One, as an executable for you to play around, where I'll write a bit of docs, where you can essentially just run it, and it will spin up a server. It will point to your you can point to your schema, and it will index the schema on startup. You just have to provide your schema, your remote URL, and your OpenAPI token. Then you can play around with this a bit. I'll also provide you with the source, but I guess most of people do not really bother with .NET code. So it's probably better if there's an executable. Steven is smiling. Java's not that far away from .NET. You just write the methods more wrong. No, you actually have the better code style than we have.
So I have one last question to this. You had also a top K retrieval for this, but the paths to the root are then always aggregated for each retrieved coordinate that you have, or are those like joined together?
So paths to the root are computed at build time.
I see. So it's a lookup table for this.
Yes. The idea is that this can be quite heavy to figure out for the LLM, and it can be there can be many paths to the root. And essentially, the idea is that we pre-build this so that the LLM has an easier life, because every query needs it, right?
But I mean, I guess the question was if you have like a top 10 retrieval of your top 10 coordinates, then you have also 10 paths, and they're provided for each. I see.
No, it's just I think I have implemented the first 10 that it finds. It's also in the specification. It's written specifically that it's open, so you can provide all, but you don't have to, right?
Yeah, we are internally, we're definitely running into problems where types, actually, Jose knows more about this. Some types have like, I don't know, hundreds of paths to the root, and need to tackle the problem of which one do we select from there.
Yeah, I guess just to put a little bit extra color on that, as we generate the embeddings and put them into the store, like Kuwei said, there's, especially for very heavy or very kind of, central types, there's a lot of paths that I can take back up to the root, especially if they pass through other kind of 4 types in the schema. And so a few kind of assumptions that get made to simplify that is to one, establish a max length, a max distance from the root, but then to also like, pre-compute all those paths to the root, and then try and optimize for like, some semblance of diversity between the paths. So instead of all paths just coming from like, query A dot B, B dot C, let's say like, let's say A was like I call like a hub node, right? Very central in the schema, lots of subtypes spawning from it. There are cases where if we don't employ some sort of diversity, or I think Kuwei and I have talked about like even more advancement, like improvements to this that we can make based on like frequency of usage of certain fields or types. But like without any semblance of diversity, really interconnected schemas, if you cut off how many paths to root you can have, you might only show a very small subset of the actual variety that can achieve that given type. I kind of spewed a lot there. If it doesn't make sense, please,
So do you prune the path to root there, or is it like, so what do you mean by diversity? So do you have like embeddings on the path lengths and have similarities on this, or?
Yeah, so we have like the way we've been generating the embeddings is like to take, parse the schema out into chunk it into the types, and then for each of them try and like trace paths up to root, right? And let's say we say we max want 20 candidates, right? And so from that result we get 20 candidential paths from that type to the root. From there, we then stipulate that, well, we actually only want 5 at the end when we embed them. Within those 20, there's some like slight computation we can do to see like, okay, what are the paths being taken? And like, if let's say there's 15 that go from like C, B, A, and then some others that go C, D, A, and C, D, F or something like that, right? We prefer diversity across like the ending 5 that we get. Because there were a lot of cases I was seeing locally where there'd be one hub node that would just be like query.rootfield, rootfield dot, or like query.user, user dot this, and then just like the same copy pasted path to my type multiple times. And so by establishing a slightly larger pool of candidates and then narrowing it down even further, we get like a more varied result. But again, it's pretty like I think the algorithm can definitely use some improvement, and I think there's like ways that we can weight the resulting score from the RAG store better from the vector search. But it's better than the very default, like, get 5 of just the exact same path.
Well, the exact same path doesn't like.
Sorry. I meant the very similar path through types. Yeah, different fields up the way. But yes.
Yeah, I mean, you can also specify them probably, like hard code it in certain cases to really make sure that a certain, when you always run into the problem that the query path is, for example, node is very short, but it's also very useless because you very rarely have the node ID, right? So that's a bit the thing. Like the easiest way to go to the root in most cases, which implements the node field, is just query.node, but it's not useful. So you somehow have to penalize this or even remove it from the paths completely.
I think that's where like the idea of basing the paths on actual usage and like actual kind of query creation. So seeing like what are the ways that kind of production queries are actually kind of reaching so-and-so field. I think maybe that also encodes in it a bit of this information you just mentioned of like, well, if nobody's just kind of short-circuiting through node, right, in actual queries out in production, can we like embed that knowledge into the aforementioned embeddings themselves?
Or maybe they are short circuiting through node because they're paginating and they're coming back and hitting it a lot, but that's never what you do first.
We have 8 minutes left. Mark, do you want to quickly talk about mock updates?
Yeah. And maybe like we can punt this over to next time, or if people feel strongly, we can have like a mid-cycle ad hoc meeting or something like that. And then I didn't make as much progress as I would have liked. Otherwise, I would have added an agenda item for it explicitly. But I did get enough to a like draft thing, which I can share, I guess, of an update to it. And as this meeting has been going on, I've had Claude. I just threw the spec at Claude and I said, go do it, and it's done it. So
love it. This is your time block of time to work on mock.
Yeah, I was like, who's gonna win? Like, am I gonna talk before Claude's finished? But like it was like to the wire, but Claude has just claimed that it's finished. Let's start at the beginning, I guess, for those who aren't familiar. And let me present this URL. Bear with me. Yeah, it is that. Public dots. Got it. Here it is. So yeah, there's also a discussion on a GitHub issue as well, some of which I'll try and find in a second, Yeah, but we started working on this, and then also, yeah, there's prior art that we became aware of as well, and I'm very glad that Michael is here in this meeting because, yeah, I think Airbnb had something on this. Netflix had a different approach, I think, to mocking, but yeah, good. Maybe we can kind of all put our collective minds to this problem. So when we're speaking about mocking, we're potentially talking about two different types of mocking. We're potentially talking about unit tests and stubbing out those requests in unit tests and mocking at test time, or integration tests, I guess. And then we could be talking about mocking in terms of you are writing a new page for trying to depend on schema that doesn't exist, or maybe it does exist, but you want to use mock data. So you might want some mocks there. So you, as a developer working on a web page or mobile screen using GraphQL data, as you're iterating on it or showing it to another teammate, you want to have some mocked data going on there. And so that's the problem space that I'm trying to focus on specifically. Maybe the two can be related in the down the line, but for now, I'm specifically focusing on that second user story of developer time mocking. And yeah, that's spec. Yes, spec markdown. That is the spec that I started putting together. It incorporates some of the feedback. It's a long process. Notably, this does now support per field mocking. I've been down a whole rabbit hole of what it would mean to mock out fragments as a distinct unit, which gets really tricky for reasons that I can go into in a second. But you can also just mock the field that returns the fragment, which is basically the same thing, or good enough, I think, and avoids a whole bunch of complexity as to, what it means to like mock out a whole fragment, which I'll get into in a second. Yeah, so that's the spec, and maybe we have 4 minutes left. Whilst I figure out how to share my screen, I'm curious if anyone has any questions. And then, yeah, we obviously don't have enough time to go through all of this. So, yeah, I'm like very interested in, particularly interested in the Airbnb folks and kind of what it would mean for like a unified approach here. Let me try and share my screen 1 second.
Thank you for putting this together, by the way. I know I had shared a bunch of feedback on the GitHub issue. Hopefully that was helpful. I'll definitely take a look at your updates, though. I'd love to see what you changed.
Yeah. I'm just going to share my entire screen and hope no one sends me embarrassing text messages or anything. So yes, here is what Claude Vibe coded, and just as a super quick proof, I guess, a new field doesn't exist yet, so we are mocking out this population field on the countries GraphQL service. If I make this request, again, this population field does not exist in the server, so we are not querying for the population field when we actually make the request, but we've mocked it out, and then yeah, there it is, returned to us. And I genuinely haven't even looked at the code yet. This is absolutely completely 100% live. Let's see, cd Apollo mock spec, cd source, cd queries. It's going to be in here somewhere. Cd GraphQL mocks. Let's just see all of this, whatever. Yeah, it's gonna be in here somewhere. This is like what the mock files look like. Yeah, here we go. Yeah, that's as much of a end-to-end demo as I can give in like the 3 minutes that I had available. Apologies that it's yeah, anyway, that's what I've been working on. yeah, Michael, I'll follow up with you once this has had time to marinate, and we can follow up on the GitHub discussion.
Sounds good.
Yeah, rapid fire demo indeed.
I loved seeing the changes, the field level mocking. Yay.
Just one quick fire question here. Are you always mocking on the fly or on compile time?
Not on the fly. That is a statement which I believe to be true today. Maybe in like a couple years or something, you know, the models will respond in near real time, and so like maybe at that point it's good enough. But my proposed workflow for now is that like you're in your IDE and you like select the field in the query that you have written in Cursor or whatever. It can be a field that does not exist yet in the schema, and then you just in the chat tab you say add a mock for this, like mock this field out, and then it takes the field that you've selected, the schema, which I guess does not contain the field for which you are querying, whatever context it can derive from the surrounding code, I guess, and it should give you a plausibly correct, you know.
Have you thought about schema extensions? Because funnily enough, like how we develop UI at the moment, or we teach people to develop UI with Relay, is to actually develop the UI without the backend because it's always very annoying to wait on us, right?
Yeah.
So what we do is we have local schema extensions that we use, and you can then write your components against the schema, and we just mock this thing away manually.
I'm very on board with that workflow of writing client schemas, writing queries on the client without waiting for the backend. We kind of used to use other strategies from that in the past. I think like LLMs offer a much better approach. I'm not familiar with schema extensions, and we don't use Relay, but I'm gonna check that out. But yeah,
because then you know the thing would be that's just from a workflow perspective would be different in terms of you would actually just have the schema extension that you want to LLMify. And then from a front-end developer, the only thing, and this is a nice thing, is you could just go to the schema extension file, slap on a new field, and then you can go to your ID and you can use it as is without any directives in there, nothing. It will just be there, and you can query it.
And how do those fields resolve? Like local resolvers or something?
Well, that's the mocking that you have to somehow get in between there, right? So it's still there. It's just from a workflow perspective for the front-end developer, it's just like, oh, I actually need to, in the Figma, we have now a display name for the user, so they can go to the extensions and hack in the display name, and then they can go back to the ID and add a display name, and then wooza, the display name is just there, you know.
Okay, so you would still want, so you would maybe want this sort of spec to like work with that as like a implementation option or something like that, like laid on top, or
yeah, I mean, I just think like this would be the best workflow I could imagine for a UI developer to be, is just to open the SDL. You know, you have the schema.graphql, and next to the schema.graphql, you have the schema.extensions.graphql. And now you look at the UI and you think, oh, actually, you know, it would be really nice if I could render this address now. You just extend the GraphQL file, go back to your component, and you just write the code.
Although in some world, client developers don't write schema, I suppose, and you know, maybe they're like familiar with GraphQL queries but not GraphQL schema, or they don't have to. I guess if it's like all done by the LM, they don't need to know about like what types are being extended here. It's all just sort of figured out.
They should. For us backend engineers, it's hard to admit, but you know, also UI developers have a say in the schema.
Yeah.
And we made very good experience with UI developers defining the schema that they want. Actually, better, much better experience than when backend developers define the schema. Because we backend developers, we don't really think about the UI. We just say, this is our domain model. There you go. And then the UI developers start implementing it, and it takes like 15 minutes after you send them that the backend is ready until they come back and say, hey, we cannot sort by username. And you're like, okay. And then you have to go back and develop. So.
Yeah. Cool. Yeah, and as for all the like fragments stuff that I was sort of hinting at as to why it was problematic, I think another piece I'm going to do is write a companion piece or something like that with the roads not traveled, like why not XYZ, and some like decision logs there, because it is like very nuanced, and I don't think the spec is quite the right place for that. But yeah, I'm going to follow up with that pretty quickly. But yeah, thanks so much for the inspiration there, Pascal. I'm gonna sort of check that out and maybe see if we can make the spec sort of like less opinionated about basically allowing for that if that's already a proven workflow. Yeah.
All right. Sounds good. We're at time. We're a little over time, actually. Thank you so much for always like a wonderful discussion, and I will see you guys next month.
Yeah. See you then. Bye bye.